record button. Am I calling her right now?
Mm-hmm.
I am? How do I do the record?
Mm-hmm.
You there?
I'm here.
So I don't know. I think it's recording, but I'm not sure.
Okay, we'll just kind of do our best. I don't know what happened. I think Carrie just got a little confused
Yeah.
on the time. That's okay.
Okay.
Hopefully, I don't know. I don't know what to do. I guess, should we just do what we normally would do?
Yeah. I mean, it looks like she already posted her own thing,
Okay.
so we can just post our own and then do better next time, I guess.
Okay, sounds good.
Hmm.
Well, I guess we can go over the preparation assignment. Do we just go over part 1 or part 2? Or all of it? I don't remember.
Let's just do it all.
Okay.
So we've got.
All right.
I did the homework. Did you do the homework?
Yes, I did.
Okay, maybe we can go through that together.
Okay.
Sorry, my nose is really bugging. Okay.
No, you're okay. I'm going to do a screen share so that you can see.
Okay.
Okay, can you see?
Yeah.
Okay. So this is what I got for number 1. I got P parentheses X.
Mm-hmm. Me too.
Then the 3 rules right there. That they can't be over 1, the number 1. And that they have to add up to be 100%, and that if you take the variable or the probability that you're trying to find and you subtract that from 1, it's going to equal the other number.
Yeah. Yep. And it can't be a negative number. Yep.
Yes, and it can't be a negative number.
Okay.
Okay, and then number 3, what does it mean to be random? I said it has a long-term pattern of distribution of outcomes.
Yep. I said we just never know what the outcome of the next experiment will be, but it follows a pattern in its distribution.
Okay. Perfect. Okay, and then for the discrete random variable, I just copied it straight from the reading. A variable is something that varies, and a variable is random, and if its value follows a specific distribution over a long run. The true meaning of the word discrete is too technical for this course. Roughly speaking, a random variable is a discrete, and its values could be listed given enough time. So that was really confusing, so I just copied it exactly as, because it doesn't really say exactly.
Yeah, it never really said, but I just put a random variable is discrete if its values could be listed in principle, given.
Okay, that makes sense. Okay. All right, and then part 2. I said the mean equals 2.5.
Me too. And
Okay.
then the standard deviation, I got 1.25.
Yep.
Okay, perfect.
Yeah.
Compared it to the one that they did, and it was the same.
Okay, perfect. And then if I can find my homework, you said you wanted to do the homework too?
Yeah, that'd be good. And I had a question on it. You see, I'll probably remember it as we go through.
Okay, yeah, no worries. Okay, so list the 3 rules of probability. We kind of already talked about that earlier, so we can skip them.
And then the probabilities, so what is the one that's missing? So you just added all those together and subtracted those from 1, and then you got 38.3%.
Yeah, so they should equal 100%.
Yeah, when you add them all together.
Yes, which follows rule number 2.
And then when you add Washington and Oregon together, it's 15.8%.
Yep.
And then randomly select student in this class. What is the probability of selecting a student that is not from Idaho? So I just did 100 minus the 21.9, which is 70.1.
Yep, which is rule 3.
Yes. And it says the probability that X will occur is 1 minus the probability that it will occur.
Yep. And then number 5, what's the probability of selecting students that are not from Utah or California? I have 81.4%.
And then randomly select a student from this class. According to the table, what is the probability of selecting a student that is not from Texas? So that one was confusing to me.
It was confusing to me too, I definitely agree. I mean, there is a chance that you could select somebody from Texas, you just don't really know. So, I mean, I said less than 38.3%, though I said there's no way to accurately determine it from the data.
Yeah, because that other could be all Texans, or it could be like one Texan, and like we don't know. So
yeah.
Okay, and then I said in the finance industry, blah 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 blah. This is the one where it was confusing. So it sounds like it can only go up by 60, 15, or 5, or down by 10 or 30%.
Yes.
Don't you think there would be other values besides those?
Yes, but I agree. I thought that too, but it doesn't. That's the only information given. I'm guessing maybe that's the only information that they calculated. I'm not exactly sure.
So I guess it says using the information in the table. So I think that's where we can just like go from there. Because I was like, you can't solve some of these because of that. But
yeah,
where it's use information in the table then. Determine the probability that McDonald's stock will go down by 10% over the next year. So I added all the values and subtracted them from 1 again and got 14, or 0.14.
Yep, I got the same thing.
Okay, and then determine probability that McDonald's stock will go up by less than 16% over the next year. Up by less than, so it's everything except for the 60%. right?
Yes.
Well, wait a second, because
Wait.
it goes up, not down, because the -5 or the -10 and the -30 don't count. That's what was confusing.
Yeah, I just counted the 15% and the 5%, so the 0.31 plus. Wait, what did I do?
Because it says will go up by less than 16%. So
Yeah.
I guess the only ones that go up are 5% and 15, but the other ones are still below that, but it's not going up. So I guess
Yeah, but they're going down. So I said I just added 15% and 5% and got 0.46.
yeah. And then determine the probability that McDonald's stock will go up by exactly 10% over the next year. And that's something that I was like, wait a second, it could, but based on the table, there's not a chance.
Yeah, and it says using the information in the table.
Yeah.
I was confused on that one too, but in the answer key it just said 0.
Yeah. Okay, so you're thinking about investing in McDonald's stock, the value more likely to go up or down. And as I think about, I added all the positives, and that's more than the negatives. So
Yeah.
more likely to go up.
Yeah, so if you add everything together, yeah.
Okay.
I believe you're correct. So up by 0.76. Alright, perfect. Okay, let me go back to you. Where am I? There you go. Okay.
Should we do the group meeting thing?
Yes. Let me get to
My
it.
computer is still being a brat, so I tried like a mouse and that's not working, so I don't think it's the trackpad, I think it's something with the computer. It's probably like a virus or something. Or it's possessed. We'll see.
Wait, what's possessed?
My computer.
Oh, okay.
With the clicking whatever it wants and submitting things when I'm not done. So
Okay, now you're fine. Okay, Math 221B, group meeting number 4. 4, not 5. Okay, so I'm hitting start.
okay, you know what? I'm gonna do it on this computer too. So let me bring this smaller, and then I'll do it on my husband's computer too.
Okay,
Then I don't have the chance of it.
I'm gonna grab my notebook. That has my notes inside it. Oh, the homework.
Do you like this meeting time? Okay.
Yeah, I mean, normally it'll be a little cramped because, like, I have work until, or I have class until 5, and then I come home. But I'll make it work. It's not too bad. Like, I can meet, so I can't meet at 2, so that one's just.
Yeah, we can do this or move it if we need to.
Here is biostatistics. There we go. Right.
I'm gonna start it.
Okay, mine started too. I'm just pulling up the reading and stuff so we can side by side.
Alrighty. Okay. So completed the preparation, participated.
Okay. So give all your probability answers in decimals. For example, 1, 2, 3, 4. Do not give them as percents.
To go.
All right, I'll read number 3. So human blood has been classified into one of our basic types, OAB or AB. The proportion of people in the population of the United States with each of these blood types are summarized in the following table. Use the table below.
I didn't know it was that varied.
Yeah.
Huh. Okay.
The blood types of the proportion gives the table and above define a probability distribution. Oh, okay.
I don't know. I don't understand.
So doesn't okay, hold on. I think that means we have to put the numbers in SPS because that's that line thing, right? It's like I don't know.
No, I did this prep a while ago. Let me see if I can pull it up.
I know I did the same thing. I did this Friday. Like I do them all at once
Oh.
so that I can just not worry about it. So I do like I do them like Friday and Saturday on the weekend in advance.
Okay, let's see.
Probabilities follow a pattern called a probability distribution. Okay, so they're all between the numbers of 0 and 1, and they have to all equal 1.
Oh, so it just pretty much is making sure that all the numbers are there to equal 1
Yeah.
at the whole. So we just add them all together, right?
Yeah, so 0.45 plus 0.4 plus 0.11 plus 0.04. Oops.
True. Right? Is that all that it's asking?
Yeah, that it follows the 3 rules. I'm pretty sure is what it asks.
Which it does.
Yeah.
They're all positive. They all are more than 1 and less than, or I mean more than 0 and less than 1.
The answer is
all
2.
add up equal 1. Okay.
Yep.
What is the probability that a random selected person in the United States has type O blood? Round to 2 decimal places. So that would be 0.45, right?
Yes.
Okay.
What is the probability that a random selected person will not have type O blood? Round 2 decimal places. So we add the other, or we take 1 minus 0.45. Which
0.55.
Yes.
All right, Carolyn Willis and her colleagues conducted a study in which dogs were trained to detect bladder cancer. The dogs were trained to lie down next to a specimen derived from a bladder cancer patient. I've heard about this. Tangle, one of the dogs, demonstrates the identification of a specimen. 7 bowls containing urine were lined up in a random order. 6 of the samples were from patients who did not have bladder cancer. 1 was from the person who did. Answer the following questions. If the dogs guess at random, what is the probability that they will correctly identify the dish containing the specimen from the bladder cancer? So, pretty much it's
1 out of 7, right?
yeah, 1 divided by 7, which is what percent?
0.143? We're rounding, right? To 3?
How many places? 3. Yep.
So
0.143.
yeah, so it'd be, yeah. I believe so. Alright, number 7. In a combined total of 54 trials, the dogs correctly identified the specimen from the cancer patient 22 times. It is very unlikely that dogs would do this well by random chance alone. Which of the following statements is most appropriate? This provides strong evidence that dogs can detect bladder cancer. There's little evidence that the dogs can detect bladder cancer.
So doesn't that have to do with, isn't there like a rule by like how much is right? Or is it just that it's more than random? Does that make sense what I'm asking? Like,
Yeah.
I mean, that's almost half the time.
Yeah.
Which, I mean, they don't detect it all the time, but it does mean that they can detect it. And you know what I mean? I don't know.
Yeah. So I'm looking at the reading because I'm not really sure. I mean, I don't know. Would you say? What do you think? Yes or no? That they can or cannot? I would say they can't.
Are we only in week 2? Oh yeah, we are, because we're course introduction counted as a week.
Yeah.
Probability. Randomness, let's see. I don't know, that's a hard question.
Okay, how about we do this? How about we think about it and come back to it?
Let's do that.
Come back to it at the end. Okay. M&Ms are small chocolate candies. Yes, they are. The M&M website previously indicated that in the United States, the distribution of color in the bags of plain M&Ms is given in the following table. If you reached into a bag of M&Ms, which is the probability of drawing a red-colored candy, it would be 0.13. Right?
Yep, because it's 2 decimal places.
Yeah, just...
Do you remember when M&M's used to have a beige color in them?
A what color?
They used to have beige. I think it was instead of blue.
Oh, no, I don't remember that. Huh.
A while ago.
Blue's the best color.
I know, I like
It's a
it.
good change. It's a good
Not
change.
that it matters, they all taste the same.
Sorry, random question I was thinking about with the blood type. What's your blood type?
I'm O positive.
Oh, positive. Okay. I'm B negative.
So you're not super common.
No, I guess not. According to that information, I'm not.
Actually, my parents are AB. So how did I end up with O? It might be I'm adopted. I didn't.
Well, somewhere in your line, you probably have an O. Both of your parents had O's somewhere suppressed. I don't know.
Something like that.
Both my parents are AB too, I think.
Oh, okay.
I'm the only negative in my family. Like everybody else is positive. So.
Well, that's a good thing, though. Then you can.
I can give them blood, but they can't give me blood.
Yep.
So I would die. Anyway, number 9. You want to read that one?
Yeah. What is the probability that a randomly selected candy is green?
Okay, so you have to add those numbers up.
Mm-hmm.
Wait, 1, 3.
Mm-hmm. Did you get one?
I got 16.
Okay.
0.16, right?
Yeah.
Okay, cool. What is the probability of randomly selecting a candy that is not green? 0.84.
Yep.
Okay.
Alrighty. Ooh, ACT scores. Ooh. Okay. ACT scores of students admitted to a medium-sized public university in the western United States were taken. The following summary statistics were calculated. Using the information from the public university to answer the following questions. Half of the observations are less than or equal to what number? What?
Huh?
Oh,
Oh, 24.3?
that will be the median, right? Because half of the observations are less than or equal to.
Okay, yeah, what's the definition of a median again? That's in the other one.
It's the one where you put it all in a row and it's the middle number. So half of them would be below that.
But what is it? Is it the median or mean?
The median is the one like that. The mean is the one where you add them all together and divide it by how many there are. But the median is the one where you like lay it all out. So you lay all your numbers out in order from smallest to largest, and the middle one is the mean.
Okay.
So half the observations are less than or equal to what number? That would be the median, don't you think?
I think you're right. I want to say you're right. It sounds right.
Or are we supposed
I
to?
always confuse the median and the mean. Like, I understand the difference between the two, but I don't really understand, like, in which situations you would use what. Does that make sense?
Yeah, well, the mean is sometimes bad because you have an outlier. So you could have like, um, I don't know. So the outlier could make the mean higher if the outlier, say you had like 1, 2, 3, 4, 12. So if you had the mean, then it would make the middle number or the average higher because of that 12. But that doesn't mean that there's an equal amount below that.
Okay, yeah, that makes sense.
I think I just got an email. Let me see.
Yeah, I heard that.
Oh, she said, I blew it. I can get on now, Karen.
Okay.
Let me see. Let me send her the. Um, let's see. Okay, I just sent her the link. Um, these it says review in parentheses, so this is from last week. So this isn't something new. So I think it would be. It wouldn't be like anything.
The next one, well, are you adding Carrie?
I just asked her to join or sent her the link. Do I need to add her?
No, she should be able to click on the link. I was able
Positive.
to.
I mean, I added you though, but it's public, so she should be able to get on, right? I
I
think.
think so. Yeah. No, I got on pretty easily, but.
Okay. Based on the information on the table above, the top 25% of students scored above what number?
So my question with this one, is it the quartile 1 or 3? Because like Q1 is the lower 25%,
Mm-hmm.
and then Q3 is 75%. So based on the information on the table above, the top 25% would be above what number? I'm guessing the top 25%, the people that scored between 75% and 100, would be above Q3, and the answer is 27.
Yes.
But that's guess.
Yeah, because the top 25% of the students scored above what number? So the top 25% would be Q3, which is 75%, which means that they're the top 25.
Okay.
So it would be 27.
Yeah, because Q1, like the average was 22. The score was 22, which is the lower half, and it's asking what the higher number was. So yeah, okay.
Yeah, the way it was worded was kind of tricky.
It is, yeah. So I'm like, okay. I think that's all of them. Okay.
The following statement is not one of the rules of poetry.
Oh yeah, the one we missed, yeah.
Oh, I'm on 13. Did you have 13?
Oh, sorry, I already answered it. I said that the one that is not correct is that the probability is high. If the probability is high, then it's positive. If the probability is low, it's negative, because there are no negatives.
There's no negatives.
Yep, so that one.
Okay. Okay, let's go back up to that other one.
Number 7. So there's if you divide 22 by 54, that's a 40% chance, 41% chance that these dogs are getting it right. Is that enough to say that the dogs can detect the bladder cancer?
Versus random would be like a 14% chance. So that's, I mean, that's pretty good. It says, it is very unlikely that the dog would do this well by random chance alone. So which of the following statements is most appropriate?
Okay, I'm going to say the first one, but I'm twitching. But I'm going to say the first one.
Because they both show it's evidence. Both of them are saying that it shows evidence. Like one of them doesn't say it doesn't show any evidence. It just says little evidence. Which is true because it's not like this overwhelming like 98%, you know.
But you're right. If it was strictly by random chance, then it would be closer to 15%, right?
Yeah. So I don't know.
I say we're right. I say the A, that it does provide evidence. Is Carrie gets on, maybe she can give us her input.
There is little evidence that dogs can detect blood. I don't know. I kind of want to say strong evidence because, I mean, if it wasn't that much of the evidence, then it would be a lot closer to 15 or 14.
Mm-hmm.
You know?
I agree. I agree with you.
So did you say that provides strong evidence then?
Yeah, that's what I said. I haven't hit submit yet, though, because I'm scared.
Okay. Okay, well, let's give it a couple minutes. And then the homework we did, and then the homework quiz we do on our own, right?
Yeah. And I did that. It wasn't too bad. I found that I do better when I do it all at once. I know maybe that's a stupid idea, but if I do like everything all at once, the preparation assignment, the homework assignment, and then I take the homework quiz, I do a lot better because it's all like fresh on my mind. Yeah.
That's smart.
So I did like much better this week. Like last week I bombed like everything because I kind of did like the group assignment, and then a couple days later I did the homework assignment, and then I tried to take the quiz. And
yeah, I'm probably gonna do the homework tonight, so I don't have to think about it.
Yeah, and I also watched the videos, which were super helpful. Before I was just like trying to fish through the reading and understand it and find answers, but
videos underneath the reading in the prep assignment.
Yeah, watching those helped a lot. Then I could actually see it, and once I saw it, I remembered it better.
Okay. Yeah, I don't think I've watched all of those. I have to check.
Yeah.
Let's give her like a couple more minutes.
Okay.
What do you think? I'm gonna put something in the oven really quick. I'll be right back.
Okay. No worries.
You can still see me though to talk to you.
Okay.
your husband, you can go ahead and start. Okay, it's been 10 minutes.
I'm checking my email really quick, see if she sent me anything. No, I don't have anything from her.
Okay.
How about we, I don't know, do you just want to submit?
Yeah, let's go through our answers again, because I might have randomly said stuff.
Okay. I'll just read them off, and you see if we have the same thing, okay? Okay, I have true, true for 1 and 2. Then 3, true. 4, 0.45. 5, I have 0.55.
Okay.
6, I have 0.143. 7, I have A, or the first one, dogs can't detect bladder cancer.
Which one? Little evidence or strong evidence?
Strong evidence.
Okay, because ours are switched.
Oh, right.
Mine's the second. Okay.
Why are the answers like that? That is so frustrating.
No.
Oh, they should be the same. Anyway, 8 is 0.13.
Okay.
9 is 0.16. 10 is 0.84. 11 is 24.
Which is the median. Okay.
And 12 is 27. 13 is, if the probability is high, then the probability is positive. If the probability is low, then it is negative. That is false.
Okay. So based on the information on the above table, the top 25% of the students scored above what number? That would be
2, 3.
27.
Yeah.
I think. Okay. The top 20. Okay. You ready to submit?
Yep. Let's do this. Sending. Hey, we got them all right. Good job.
Woo! 100.
All that nervousness for nothing.
What a relief.
Okay, well, I guess that's it. I don't know if Carrie emailed you. You can respond to her and ask her if she's done the quiz already.
Okay. Okay, so I'm going to stop broadcast and then hopefully use the same. Do I use the same one that I sent you?
I do not know.
Okay.
I have never actually done that before.
We'll try it out. We'll see how it goes. Okay.
And once you do, let me know so I can figure it out if I ever have to.
Okay.
Which link?
Okay. Plan Wednesday at 2, right?
Yep.
Okay.
Wednesday at 2, I'll be here. Okay, see ya.
Okay, bye.
Bye.